The reason I'm doing this check is obviously to make sure everything sounds all right. Let me just see what YouTube Studio has in store for me. Checking. Everything sounds all right. Let me just... Okay, I think we're good. I think we're live. Okay, sweet. So we should be live on YouTube and also Twitch. So that's pretty cool. All right, so welcome to another installment of our weekly roundup. So in weekly roundup, what we do is we go over previous questions on LeetCode that we weren't able to solve in this past week of doing our daily LeetCode streams. That way we can try to hit every single easy question, just because I think, that's what the goal is right now. And we're doing pretty good on that. And let's just remind ourselves of how far we've come. We're almost at the 200 question mark, which is amazing. I mean, 161 questions. I think we're maybe almost 7% done with all the questions on LeetCode, so we're definitely making progress. For anyone that's new around here, I've been doing daily LeetCode live streams for about a month. I think today is actually the 1 month mark that I've been doing this. I'm very happy with the growth. I'm very happy with the community participating, and I truly hope this helps a lot of people looking into getting into LeetCode for the first time. One thing I should mention that has nothing to do with the stream, but it's a little bit stormy right now here in South Florida. So if you're hearing thunder or any sort of background noise, I apologize for that. Maybe there's some filtering I can add to make it a little bit more, to deafen that background noise, but just want to let everyone know. Also, I have this website I created called Raphael's List that condenses all the questions we've worked on so far into the list of top quality questions that I've identified. Each one has a stream clip that you can go to, which takes you to the specific video in YouTube where I talked about that and the specific chapter. We of course have a link to the LeetCode question and then a list of topics if we need some extra help. So if you're watching this, you really enjoy this, make sure you subscribe to the channel. It's going to keep me motivated. It's going to keep me wanting to do these videos. And if you're really feeling good, make sure to click on that notification bell. It's going to keep you notified of any single time I go live. And that's exactly what I want to do. So without further ado, let's go ahead and start on LeetCode and let's see where we left off. Let's see the first question that we need to tackle. So typically I sort by acceptance rate, and like in this week I've been going directly to page 2 because that's where we are, but now we're just going to scroll down the page and find the first question that we haven't solved yet. So let's find which one that is. So it looks like we have a new one here just to go through. So we have number of arithmetic triplets. I think this might be a new question. I don't remember this one before. So let's see what this one is. So far it looks like it's a high quality question, which I'm really happy about. Let me one more time just check the stream real quick. Always wanna make sure. Let's see. More time, just okay, cool. Awesome. All right, so let's see what we have here. You're given a zero indexed, strictly increasing integer array nums and a positive integer diff. A triplet ijk is an arithmetic triplet if the following conditions are met. I is less than j is less than k, and nums j minus nums I equals diff, and nums k minus nums j equals diff. Return the number of unique arithmetic triplets. So okay, so we're given a strictly increasing, so it's already sorted for us. So that's gonna be good, right? A is less than k, and we have j minus I is equal to diff. So I think we just want them to be all, this is 4 minus 2, and 7 minus 4 equals 3. Oh, wait a second. 5 minus 2, nums j minus nums I is diff, and nums k minus nums j equals diff. So 1, 2, 4, index 1, 2, 4 is an arithmetic triplet because both 7 minus 4 equals 3 and 4 minus 1. Okay, so based on this, I think this sounds to me like, we might be able to use like a 3-pointer technique here. I don't know, it might even be like maybe a sliding window type of thing, but let's see what we can do here. So let's imagine we start off in this array, right? And we have I, we have j, and we have k. So at any point, since this is already in order, we're looking for 3, right? So 4 and 1, like this is 3, but 1 and 0 is not. So if this is not, that means I need j to be bigger, but then that also means I need k to be bigger. So like how often should I increase j, right, to do that? Like if I increase k and then I increase j, okay, we get there, that's fine. And then I get to the next one, maybe that's okay. I mean, one way that we can definitely do this is by doing brute force. Perhaps we should try and do brute force first, and then we should see, the fact that they're really emphasizing strictly increasing makes me believe that that's a hint. That's definitely a hint that they're giving us. Something that we can take advantage of. So let me see if there's like, before I even do that, can we do this in a nicer way? If I had the difference of all of them. Oh, but they can be at any index, right? So anytime, like 1, 0, 4, 0, the distances of all of them. Let's do this. Let's just do brute force in the beginning. So let's say triplets equals 0. Here we can say for let I equals 0, I less than nums dot length, I plus plus. For let j equals I plus 1, j less than nums dot length, j plus plus. For let k equals j plus 1, k less than nums dot length, k plus plus. All right, so we're just considering every single triplet. And now we can essentially just do this, right? If nums of j minus nums of I is equal to diff, and nums of k minus nums of j equals diff, then we can just say triplets plus plus. And here we'll return triplets. Let me just make sure I spelled all these fine. So let me just run this and see what this gives us here. So 2 and 2. Let's get to the next one. 2 and 2 again. So don't really have a lot to go off of there, but let's see what this gives us here. Okay, so wow, 100 and 100. Like, can we take a, man, I really want to celebrate this moment here. I'm gonna take a snapshot of this. Wow, haven't had that in a while, especially in JavaScript. So that's pretty nice to have. Now, is this really the best that we can do here? You know what it might be though? 100, 100 again. There's no way that this is more efficient than doing. Really? Wait a second. N diff and n minus 2 times diff, hash set own codes, easy hash set. Okay, I was about to say there's no way that that's the best that we can do. There's certainly a better way that we can do this. The diff is 3, so we want j. Let me see something here, because what is there like a better? So nums of j minus nums of I is equal to diff, and then nums of k minus nums of j equals diff. So nums of j is diff plus nums of I, right? We're just doing like some math here. So nums of j is equal to this. So then in nums of j, we can do this, right? I can say that this right here, right? Because nums of j is that. So nums of k minus diff plus nums of I equals diff. Now, how does this help me? I don't really know. Now, wait a second. Plus, if I remove the diff from here and add it to diff, that just cancels it out, right? So are we just looking for any time that this is true, where nums k plus nums I equals 0? So if I have, let's see, 1, 2, 4, 1, 2, and 4, 7 plus 1 is certainly not 0. So I think I did that math like entirely wrong. Terrible math. But that's fine. That's what we're here doing this, right? Just learning. But the arithmetic triplets, how can I store? It'd be nice if like I had, do I need distances of all the previous ones? Or if we add 0 plus 3, like, is there a 3 from 0? No. But there is a 6. 6 minus 3, no. How about 1 plus 3 is 4. 4 plus, okay, that's 7. Can we just count every triplet to see if that's ever the case? Like 0 plus 3, that's already false. It doesn't exist. 1 plus 4 does exist. 4 plus 7, that does exist. So that's 1. 1 minus 4, no. 4 plus, and then 10, okay. That could be 1. And we have 1 minus, no. If we get to 4, 3 plus, okay. What I'm doing is like I'm adding 3 and subtracting 3 from every single one. If I do 4 plus 3, that's 8. That's 7 plus 9, that's 10. It's not there. So then there's nothing else to the right. 5 plus 3, 8. Okay, that's not good. 6, 9. Oh, we're doing 2 though. 4, 6, 8, that does exist. 5, 7, 9, that does exist. 6, 8, no. 7, 5. But we've already done this one, right? Is it okay for me just to go... Can we just look to see if there's like... Wait a second. This is increasing, right? So can't we just add? Like at 0, does there exist a... Oh, I think I know what we can do here. Triplets is 0. Very curious. Like for let I equals 0, I less than nums dot length, I plus plus. And maybe in here, like we want to be able to find this, we could do like a binary search, but that seems crazy. Because what I can do is at any point, can I just say, does there exist a 4 and a 10? And we can do that. Maybe we can do this in n log n time. That's with no added space. Yo, Marvin, what's up, man? Good to have you around. I know this time I didn't have like a clear idea of when I'd go on, so I wasn't able to schedule this ahead of time. The weekend ones are always a little bit more hectic, and today's a little bit more of a busy day, so I know I kind of just randomly came on, but I'm glad to see that you're around. So yeah, like one thing I was thinking here, I can also put all these in a set. I can put all that in a set. What if we had like const values set equals new set of nums, and then we can have let triplets equals 0, for let I equals 0, I less than nums, or maybe we don't even need, like for const value of nums, if, let's see, we can do const next. Oh, we can say if, I'm going to make this a little bit bigger here, if values.set.has value plus diff and values set.has value plus diff times 2, right? Because we're looking for a 0 and a 6. Here it would be what? So like we're looking for a 1 and a 3. Yeah. Then we can just add triplets plus or equals 1, return triplets. Let's see if this works here. 2, 2. I started backtracking today. Shake my head. It had me rethinking everything today. Yeah, backtracking is complicated. The good thing about backtracking is the template is sort of the same, but there's like the one piece of backtracking that's like, okay, this is where the real logic is. I'm really looking forward to getting to the more backtracking algorithms, especially once we cross over into the medium territory. We'll definitely be dealing with a lot more of these. That's going to be really cool when we get to medium, because everyone, when they think about LeetCode, I think they generally think about mediums. I think easies are going to be like good preparation. Once we get to medium, that's where probably most of the learning happens. I would say hard territory, you're learning a lot for sure, but it's not as rapid as medium, I don't think. Like you're much better when you go from easy to medium than when you go from medium to hard. I think that's how it works. So let's see this. So far our test cases pass 2 and 2. Let's submit this. Okay, so still 100, 100. Now, why does this work, right? And to be fair, I kind of got a hint from the discussions, which I regret a little bit because I think we could have figured this out ourselves. But this is already sorted in increasing order. So you saw that we did the brute force solution, which is when it's going to be a cubic algorithm. It's going to have 3 nested loops. Yeah, the logic really is like magic. I totally agree with you. So we did the 3 nested loops here. We got to a cubic algorithm, so n cubed. And the space complexity for that one was constant, which is a benefit. Then we also get to this one where really all we need to do is at every single value, we want to check if the value plus the diff exists and the value plus the diff times 2 exists, right? Because we just want to see, is there like a 0 plus 3 is 3? There isn't one, right? Is there a 1 plus 3? Yes, there's a 4. Is there a 4 plus 3? That's a 7. Yes. So that's where this comes in handy. Now creating a set, this is O of n time, and this will take O of n space. In here, it's another O of n, right? So now it's linear time, so we're drastically reducing the time complexity with slightly more space complexity. Now, something that we could also do, kind of like maybe the middle ground, perhaps, is since this is sorted, we can actually do a binary search for the different numbers, and we can say for every one of these, right? I'll draw some pseudocode here. We can have for const value of value, we're going to, let's see, do binary search in nums for value plus 3, right? Or let's say value plus diff, and then we're going to do another binary search for nums in the same array, value plus diff times 2. Does that make sense? Because we want to search, and actually we don't even have to go from low to high. Like the low can be the index we're currently on, the high will always be the end. That could be like a slightly different optimization that we can make. And if we think about this, each one of these is going to be n log n. So this is 2n log n, which is just n log n. So this will make it n log n, but with constant space complexity. So I like this question a lot because it allows for us to, like, there's a lot of cool things that you can do here. And you know what? We should implement this. But let's go over the different things we have. So the first one is brute force. So we do I guess a 3 times nested for loop, right? 3 times nested for loop. This gives us a time complexity of O of n to the cube, or 3, n to the 3. Space complexity is going to be constant for this one, right? And now let's get to our next one here. The next one, the one that we just solved, is use a set and look for diff, which is the one that we just did now. This will be a time complexity of O of n and a space complexity of O of n, right? And the one I'm proposing now is use binary search. Use binary search. This should give us a time complexity of O n log n, but a space complexity of O1. So this question offers many different ways to do this. And let's go ahead and figure this out. So we're going to implement just like a standard binary search. So I'll implement this up here, binary search. This will take an array, the array that we're going to perform our binary search on. And now let's say, and also we should pass in the low, right? So let's say let mid equals 0, let high equals array.length minus 1, while low is less than or equal to high. We'll calculate our mid, math.floor of low plus high divided by 2. And then here we say if, and then here we need to pass our target, right? Our target. So if the array at mid is equal to target, then we return true. Else if the array of mid is less than target, then we say our low equals mid plus 1. Else if the array of mid is greater than target, we say high equals mid minus 1. And at the end, we just return false if we never find it, right? So what is it that we want to do? We can now just, I think we can get rid of our set. We'll set triplets in here. Now we do, for const value of nums, we can say binary search. So we can say if, right? Now we're going to do if binary search of nums, right? The low needs to be the index we're currently on. So we're actually going to rewrite this whole thing. This will be for let I equals 0, I less than nums.length, I plus plus. Let me just de-indent this. If binary search of nums, low is going to be where we currently are at I. The first target will be value plus diff, right? If binary search of this one and binary search of nums I value plus diff times 2. here we can say triplets plus or equals 1. So let's try this out. Let's go through our test cases. Let's see, I value plus diff. Oh, did I do, this should be nums at I. Nums of I. Let's run this. 2, 2. Okay, awesome. Let's see what this gives us. Okay, so we literally got 100% for all of them, which is a little bit strange because we got 100% in both time and space for all three solutions, even the cubic one, which I find hard to believe. But this is a fantastic question. I mean, we did 3 separate solutions here for a single question. I feel like this is a really good like bang for your buck question. I mean, phenomenal, because you get to practice 3 different ways of implementing an algorithm, and you really get to like just like flex your algorithm muscles. So I really like this question a lot. So that's super cool. I'm really happy we started the stream off with this one. Okay, nice. Man, it's a little bit unfortunate. Like someone followed me on Twitch and it should have shown something on the screen for that alert. But it's fine. But I appreciate the follow. I think it's Troll5662. Really appreciate the follow. All right, let's go to the next one. So that's the first one. Remember, weekly roundups, we're just looking at the ones starting again from the beginning of the list of the questions we have yet to solve. Okay, so that means, okay, we've officially done, as of right now, this might change, right? Because the question we just looked at, we hadn't done before, but we've officially done every single non-premium question on this first one. I think, and I don't even know if I can do this. If I buy premium, can I stream myself doing premium questions, or is that like, am I giving away free content? Am I giving away content that should be paid for free? I don't know. But that might be something that I do. Yeah, perhaps. We'll get to that when we get to that. We'll cross that bridge when we get there, right? We have a lot of work to do. All right, the next page. Okay, remove palindromic subsequences. I think this question was really hard and it was just kind of annoying, but we're going to figure it out this time. I mean, look at that like to dislike ratio. It's not good. Okay, so you're given a string S consisting only of letters A and B. In a single step, you can remove one palindromic subsequence from S. Return the minimum number of steps to make the given string empty. So like, oh, Segoy, hey man, what's up? Do you participate in contests? No, I don't. But like, so let me, I guess as a teaser, like what I'm planning to do with this channel as I continue growing, like right now I'm doing the daily LeetCode live streams, and this is like a nice intermission here. I appreciate the question. But if we go on LeetCode, right, like something else that LeetCode has that I think it's really nice are also the explore section, which I think is great. So what I would like to do is I'm planning on also making playlists for each one of these different learn sections. Now, of course, some of these sections are going to cover questions that we've already covered, but I want to make it a little more focused. So let's say you go to the YouTube, right? You go to my channel and you're like, okay, I'm looking to just do all the easies. There should exist a playlist for that. But imagine that you want to be a little more focused and you're like, well, man, I really wish that Raphael had like a playlist for linked list, right? I might go, like I want to create a whole playlist just for linked list, a whole playlist just for graph, and like I'll redo questions again, but now it's going to be just more focused, right? Everything's going to be around the same data structure. So that's like one thing I plan on doing. Contests, I think it would be super cool if, yeah, like when I grow the community a lot, it'd be awesome if I can like live stream a contest and have a ton of people doing it with me live. And, you know, like we'll see whoever wins. It'd be cool to even like promote those people. I can say, oh, like one of my audience members, you know, finished the contest and I would love to have like their name on my website or something up here. Like this website will continue evolving, right? So a ton of different things I can add here. That's like one thing I want to do. Did someone else mention? Oh, contest. Yeah, explore section. And then maybe, yeah, even do like some of these study plans. I mean, there's a lot of different stuff that a lot of different things that we can do. My main thing right now is growing the YouTube channel, making sure that I can stay consistent with the videos. And then, you know, we'll cross that bridge when we get there, sort of thing. Like you'll know, like, especially to be completely honest, like, again, I've said it a lot, but I'm really trying to hit 500 subscribers because that's going to allow for me to do community And the community feature on YouTube is awesome because I really want to be able to gauge what the audience wants. I can like have posts with different polls. I can see like how the audience wants me to make videos. I can get a lot more feedback. So I really think that's going to allow for me to grow in a different way. But of course, like anything that's worthwhile, we'll get there eventually. And I think we've made tremendous progress. So really happy to have you guys around. Both Segoy and Marvin, you guys have been like, you guys are the OGs. Like when we reach past 1,000, 2,000, however many subscribers, I'll always look at my chat list and I'll be like, man, Marvin and Segoy have been there since the beginning. So that's super cool. Anyway, enough with that tangent. I'm just happy that you guys are around. Let's see if we can figure this one out. This one's tricky. So a string S consisting only of letters A and B. In a single step, you can remove one palindromic subsequence from the minimum number of steps. So when I think of minimum steps, it means that like ideally I would find the largest palindrome. So maybe I wonder if like at any point, how can I find the largest palindrome from here? Like AB, right? I mean, this one is a palindrome already. ABB. What's the first palindrome that I can remove? Should I just always try to find? Let me think about this. If you give me a string and I want to find, because there's a question that's like find the longest palindrome, but that's a medium question, I believe. Subsequences don't necessarily need to be contiguous. So it can be just like, yeah, right, A, B, 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 A, A, B, B, or B, A, A, B, which makes it like doubly complicated. Can we like take advantage of a stack here? I don't think so. No. Because when I think of string parsing, I also think of a stack. Now, what happens if we sorted the string? No, we can't sort the string, right? Because that's gonna mess up, like, it's not a stable sort, I guess. We need to keep it stable so the items are relative. I think that's the right terminology. I really want to get to this one. Does not necessarily need to be contiguous. I'm going to think about this one for a little bit. Actually, give me like 1 second. I'm just going to get a drink of water. For some reason, my Be Right Back screen doesn't have any more like music like I used to. I need to figure that out for tomorrow's stream, but give me like a minute. I'm just going to go to my kitchen and get water. I'll be right back. All right, cool. Let's see. Minimum number of steps to make the given string empty. Like at every single point, we want to find the largest palindrome so that we can remove that whole thing. So can I just start at some point and go outwards? Like, how far? ABA, because like, well, in that case, if I were to do that, oh no, we can't, because again, it doesn't need to be contiguous. It can be any letters. BAAB. But why can't it be BAAB? I guess it'll be the same. Do we just need to find ABABA? And I also can't rearrange the letters, I guess. Or remove palindromic subsequence A and then BB. S is already a palindrome, so its entirety can be removed in a single step. Remove palindromic subsequences. This is one of those types of questions that's like you can have a lot of practice doing LeetCode, and then you run into something like this where you've just never seen it before. So we know we can't sort it. A string is a subsequence of a given string if it is generated by deleting some characters of a given string without changing its order. Subsequence does not necessarily need to be contiguous. It reads the same forward and backwards because this is an A, this is an A. If I go in, BB, if I go in, that's A. If I start in ABB, I mean, what if we just have like, if I always assume that the two indices on the furthest edges will be palindromes? Yeah, I feel like that's something like that, right? Because like, what if we had I and J, and I'm like, okay, this is like one of them has to match the other. So let's say I want I to match J, so I is A, so I decrease J until they're both the same, and I remove that one. So what if I do the same thing here, like I and J? Okay, I and J could be a palindrome because these are both the same. So let's decrease this one and come to this one. No, we can't decrease that one. So like BAAB. I can't decrease that one, but I could include A. Or do I? Is there another way that I can do it without having to? BAAB. Have a B and a B. Okay, remove that one. But then I'm left with AAB, and I don't want that. B and B is fine. The next one's an A. Do I just alternate? Or I guess at every step you make them equal. Do I just make them equal at every step? So like I and J, that's equal. You're gonna increase one. Now you make, but like which one do you choose? Do you choose to make it equal to B or do you make it equal to A? Like why would I not make I go to B? Why would J come down to A? Yeah, this one's very tricky. And like this right here, that more people dislike it. Does that mean that people are like, this is definitely not an easy? Does that mean that typically this can mean that it has a lot of like crazy edge cases that makes it particularly hard? Minimum number of steps to make the given string empty. What happens if we just kept the frequency of this though? Does that even matter? Like what if I have 3 A's and 2 B's, right? Like given this frequency, right? Because if it's an odd length string, wait a second. I think we know something here. 1, 2, 3, 4, 5. That's an odd length. So odd length strings can have one odd, right? Can have one odd character. Or by that I mean like we can have like 2, 2, so this is fine. Now in this one, this is also here. What do we have? B, A, B, B. We have 3 B's and 2 A's. Oh, but that's the same thing, and we still can't because we don't know the ordering of them. So it's not so much of like how many we can make, it's the ordering. B, A, B. What if we take the count as we go along? A, B. But then again, how do I know to stop? Because if I'm at A, I'm at B, I'm at another A, so I have 2 A's and 1 B, so I could make a palindrome out of that. But why would I stop there and not continue going? I don't like this. Yeah, me neither. Nice, love your channel. Oh, hand sanitizer. That's a new. I think I saw your comment earlier today on the Triplets matrix. I think I saw your comment, hand sanitizer. Thank you so much for the support. I'm really glad to hear that you love my channel. I was talking a little bit earlier on the stream of like how I plan on growing it. So once this video goes live, you can like go back to that piece and we'll talk about like I have like ideas to continue making content for this channel and like really trying to give everyone good value for spending their time watching my videos. So love to hear that. So I'm really happy that you're around, and yeah, man, like hope to see you around more often. Maybe we use 2 pointers. We put I0 and J last, then we check the string from I to J as a palindrome. If it's not I++, yeah, like we probably could do that. It's just, I get stuck in this thing of like beginner's luck, like risk. I feel like risk taking is very important in LeetCode. What do I mean by that? Right now I have tunnel vision because I'm trying to think of an optimized way instead of just trying to get something out. And maybe that is the optimized way. Like at every step, we just check to see if we can make a palindrome. But like, so here, if it's not, so from here to here, can I make a palindrome? No. But that's the thing. I think the only thing with that, Segoy, is I think in your case, we would consider every character, but it doesn't need to be contiguous. Because see, like for this one here, they're saying that BAA, well, it could be BAAB or B. I guess that's okay. ABAB. Yeah, we start at either end. We can make a palindrome for the whole thing. So that's cool. Now we come here. AA, the next ones should match. See, my thing is though, like, oh, wait a second though. I guess that would work, right? Because even if we're at BAA, we can start at I in here, these match, then we want the next 2 to match. It doesn't matter which ones I pick. If both of them match A, then we'll have BA, oh, but then we'll have BAB, but then AB is not a palindrome. We need to have BA, let's see, we have B and B, okay, then we increase I, we increase J. So I can have, oh no, I can have J be the B, we'll delete that one, and then do another one. Now how do we keep track of all the characters that we delete? Do I need to always delete them if they're equal? So maybe, I'm gonna try that you mentioned, Segoy, like, so I have pointers on either side. While I is less than or equal to J, we can find same cars and delete. Or we can mark them for deletion, because if I'm deleting them as I'm going, that's not going to be good, right? I should only delete them after. Can we delete? Oh, yeah, I'm not in love with that. I'm really not in love with that solution. I can come up with a nasty algorithm here, but it's not good. How about this? S.length is less than 1,000. Will that help me at all? I don't think so. Having the frequency is not going to help. So let's see. Let's start equals 0. Let end equals S.length minus 1. I'm going to create a copy of this string. Like copy. And what if here we have while copy.length is greater than 0? I think here we should do this. While copy length, let's start equals 0. End is equal to copy.length minus 1. Right. That's what I'm thinking, Segoy. That's exactly what I'm thinking. So here, let's see, while start is less than or equal to end, I guess anytime the thing, let's do like const to delete. I want to make an array of the indices that I want to remove here. So while start is less than or equal to end, they both should equal each other. So let's do while, and I'll try to explain all this as I'm going along. So while copy of start is not equal to copy of end, start plus plus, while copy of end, well, I guess if as long as one of them is the same, maybe this is the only thing that we need here. Let's see. While copy of start not equal to copy of end, start plus plus. Okay, so let's use this as our example here. We have start and we have end. They're already equal. So maybe here, what is it that we do? We can put to delete dot push start and end. I'll go ahead and push two things. And now can I just increase? Can I do start plus plus and minus minus? So this will be start plus plus, this will be n minus minus, while copy of start not equal to copy of end. So this will go all the way to the e. And then we'll just push. Let me make this a set. That way I'm never including more than one of the same. Use set. Let's do to delete dot add. Start and end. Does add take, let me see something, mdn set. Can I add value? Okay, so maybe instead of doing this, I'll just do add start and to delete dot add end. Okay, I should also make sure that it's not equal to m, but start should be less than copy dot length. And okay, so then start will go all the way to e, and then now this will fail. So now what I would like to do is go through and delete everything inside of, delete all the numbers inside of set. Now let me see something else. If I do array splice JavaScript, can I take how many removing or replacing existing elements, delete count, item 1, item 2. Ooh, that's nice. Oh, that'd be so nice if I can item 1, item 2, like for each one. What's the easiest way for me to go through? I guess I think I can iterate through this, like for const index of to delete dot values. It's going to give me all the values inside of here. Let's see, we can do copy dot splice. We don't want to insert anything, right? We're doing what? Start, delete count, item 1. Oh, okay. We want to start at the index and we want to delete 1. Copy dot splice index, right? The index we get in here, we're going to delete 1. And then we need to get our, let's say like remove, what does it want? Minimum number. Let's say min steps equals 0. At the end of this thing, we do min steps plus plus. Because I'm going to create a new set anyway. All right, so let me show you what I'm thinking about doing here. Let me just like go over my example. Let's try to go over all three of them. So we have BAAB, we have start, and we have end. And we have copy.length, right? We're just creating a copy of a string. We're making it into this array. Start 0, end is copy.length minus 1. And now we have our new set, which I'm going to denote by putting this object literal here. While start is less than or equal to end. So while start is less than copy.length and copy of start not equal to copy of end. That's false here, so that's fine. We're going to delete start, which is 0. And we'll delete end, which is what? 1, 2, 3, 4. Now we'll do start plus plus and end minus minus. Well, start is less than copy and copy of start not equal to copy of end. So we'll increment s until it becomes the one at e, right? At end. So I'm just going to put start up here because now they're the same. Okay, so now we're going to delete 3, right? We're going to add 3. We're going to add 3 again, but it's in a set, so we just have these 3. Start plus plus. So now we're in this scenario. So now this is false. We now go to here, and for all of these ones, we delete 0. So this, we delete 4 and 3. Now, that's going to also, that might not work. This is not sorted. It's going to delete 4 first. And then it's going to delete 3, but that's going to be out of bounds. So I think what I'll need to do is I'll need to like, start and end. Am I going to need to like sort this? That doesn't sound nice. I feel like the delete part is not something I really need to be concerned about, because it'd be nice if I mean, it's certainly a way of doing it, but really I don't love it, but let's give it a shot. It's not going to look nice, but sorted indices. Okay, this is going to look like some weird syntax, but we're going to take toDelete.values. We're going to spread this into an array, right? Because toDelete.values, I think if we look at, again, mdn set, this just returns an iterator object, I believe. Yeah, so we need to spread this to make it into an array. And then we should be able to sort that, right? So I'm going to turn this into an array, and then I'm going to sort this. And then what I can do is maybe start from the back, right? For let I equals sorted indices dot length minus 1, I greater than or equal to 0, I minus minus. Perhaps here we can do copy dot splice I1. So if we're deleting from the back, it should be fine. Nice. Yeah, embedded programming. Man, I bought a book for embedded programming like way back when, because there was a moment in my life where I wanted to essentially get into that. So that's pretty neat that you're doing that. Okay, so let's just like run this to see what happens. This is a weird, this reminds me of like the Goat Latin one. Undefined. Nice. Oh, wait a second. I just didn't return it, right? This is a very specific. Okay, A, B, A, B. Okay, that's good. So far the first test case passes. I'm happy with that. 1, 2, 2, 1, 2, 2. All right. Let's see the moment of truth, man. We're just going to go for it. Ah, man. I was so hopeful. I was so hopeful. A, B, B. So output 3, expected 2. Probably something like I'm missing here. Obviously, there's something I'm missing here, right? If there wasn't something that I was missing, the answer would be right. Let's see what we get. So start and end. So I want these to be equal. So I'm going to start from here. Oh, but you know what? Maybe it's because I'm not almost. Yeah. Now let's see how many test cases I passed to see if I was actually almost there. 27 out of 48. So I mean, maybe we got like a little more than halfway. So that's nice. Let's see. So for this next one here, 1 second, guys. I have to step away for 1 minute. All right, so let's get back to it. So I think what I'm missing here is like maybe, yeah, you know what? Because technically I think, well, let's just go for our thing, right? So I'm going to get to this point, right? Because I want my S to match. Now I'm going to add 1 and 2, 3, 4, 5, 6, 7 into here. I'm going to reduce each one of these. Now I want the S to become an A. Right, so I'll get here. I'll add these 0, 1, 2, 0, 1, 2, 3, and 6. I'll keep doing this. I'll get here. Now we'll add 4 and 5. And then we'll get to the midpoint. That's fine. So we'll delete all these. So I wish we can really like see, because can I do like A, B, no, okay, A, B, so B, B, A, 3 and 2, min steps plus or equals 1. If this is sorted, it's what? 7, 6, 5, 4, 3, 1. 7, 6, 5, 4, 3, 1. 0, 1, 2, 3, 4, 5, 6. We delete 7, we delete 6, 5, 4, 3, 1. And then we're left with AB. Copy dot splice min steps. Let's like, maybe we should print out. Let me get this here. It's always good to see. Let's see if we can do console.log copy. Oh, you know what? I actually just want to see. I just want to see this one. And you know what? AP3, output 3 expected 2. Maybe I should, let me do it before. Like right before I delete. Because what did it look like after that first deletion? So this is all of them, and at the end we ended with AB. Okay. So could I have made, it seems like I should have picked a longer one and I didn't. But where can we, because I can't do AB in the longest one here. Now, can I do B? Or, oh, maybe it wants us, oh, you know what? It wants me to pick AA, because we can do AA and then these two A's and then this A, and then we're just left with BBB. But my thing is always trying to set start equal to the last one. So like at any point, why? That's so weird. Do I need to keep track of like the frequency, like which character has the more potential characters that I can remove? Like, could that be helpful? Maybe like I pick the one that has the largest frequency, because the one with the largest frequency is the one that I can remove. Like in this first one, A has the largest frequency, so make either of them equal to one with the larger frequency. B has larger, let's try that. Let's try that. Okay, so we're gonna have to add another thing here. We'll say const frequency. We'll say for const C of S, frequency of C equals frequency of C plus 1 or 1, right? So now we'll have the frequency of each one of the characters. And now for here, we need to see the one. Yeah, so we want the match to be with the one that has the greater frequency. So it should equal the one that has, okay. Const larger frequency equals frequency of start greater than frequency of end. Pick start or end. Wait, is this going to give me? That's not going to give me. If larger frequency is frequency of start greater than frequency of end, then we should just pick the thing that's copy of start or copy of end. So now we can say, well, start is, yeah, and I guess here what I can do is I want each of these. So while start is less than copy length, and copy of start is not equal to larger frequency. Let me just remove this, start plus plus. Perhaps I can have another one now. That's while end is greater than or equal to 0, and copy of end is not equal to larger frequency end minus minus. So I want them both to equal larger frequency, which is going to be some character. Copy start, copy end. Oh. Let's see. Oh, still 3? Let's see. So I take my frequency up here, frequency of C plus 1 or 1. Okay. While start is less than end, larger frequency of A is greater than frequency of B. 1, 2, 3, 4, 5. 1, 2, 3. Yes, it is. So copy of start, which is 0, larger frequency is A. So while start is less than copied out length and copy A is not equal to A, which it is, okay. While end and copy end is not equal to larger frequency m minus minus, so it should go here. Start plus plus n minus minus. Oh wait, we should only, I think, oh yeah, wait, there's a couple other things I have to do here. Like the largest frequency is always going to be, which one's going to have the, oh yeah, this is crazy. Do I have to actually do this? I think I should do this out here. Calculate our largest frequency once for the new string that we have. But every single time I get to that, I should decrease frequency. We're always going to be deleting 2 of them. So maybe we should do frequency of larger frequency minus equals to 2. This is very, like, at this point, we're just solving this algorithm to solve it. It's like, we have like a random 2 here. It's very nasty. 6, oh, that's even worse. And why did this thing grow? Frequency of larger frequency minus equals 2. That's going to equal a character. Okay. Wait, that's super strange. How did copy get larger? Wait, what? How did AABB? While start is less than end, we're going to start plus plus, okay. Start is less than end. Frequency, larger frequency minus 2. This is so weird. Maybe this wasn't like the right way to go here. I almost thought like by us, like at any given moment, like once we remove all the characters in the current string with the largest frequency, we should always focus on the one that's larger. But maybe we only need to do it, maybe. Unless I do this, okay, let me put this back in here. Because maybe, because every time I'm deleting strings, copy is being modified. No, wait, I'm not actually deleting strings in here. I think that's just going to end up being the same. 3 and 2, still 3 and 2. I thought that would get us closer, but apparently not. But that's okay. I mean, we made really good progress on this one. It's probably going to have to be one that we come back to again, unfortunately. Let me see. I do have to cut it pretty close now to an hour because I have like a pretty busy afternoon ahead of me. But let me see what, just for fun, let's see what the next one is. Counting bits, final prices, remove palindromic. We weren't able to do this one last time. Final prices with a special discount. Oh, this is a good question. We should start off with this one. I guess we'll have to get to this one next week. But like I'm really happy with the stream for a couple of reasons. I feel like we had some new faces show up, like hand sanitizer. Really happy that you were able to make it here. One of my favorite questions that we did today was for sure like the first one, which I hope it didn't ruin my ordering here. So algorithms, let's go to page 1. The what was it? The arithmetic sequence. Yeah, number of arithmetic triplets. Like if there's one thing you can take from this, I would highly recommend focusing on the beginning of the stream where we did this question, because we solved it in 3 different ways. So it gives you 3 different solutions. Like you get to see like a brute force cubic using a set and looking for a difference to reduce it to linear, but also increase the space. And then even this mid ground of using binary search of getting n log n and then 1. I'd probably argue that time in today's day and age is more important than space. We have enough space, I think, to account for a lot of the extra space that we'll need. But for time, performance is good. So, but definitely focus on this part in the stream. And this next one is just an unfortunate question. We'll definitely get to this before we ever move to medium, but it'll require some more thinking on my end. So with that being said, I really do appreciate everyone's participation today. I'm going to go ahead and upload. I'm just going to add this first one here, which I already added to my list to my website. So you guys will be able to access it via the website if you're visiting that. And yeah, just, if you liked what you saw today, make sure you subscribe. Make sure you ring that notification bell. It's going to really help me continue to grow my audience. And like I said, my next big milestone is getting to 500. That way I can unlock community and really like gauge the audience, interact with the audience, see what you all want me to do, and we're just gonna have a lot of fun with it. So thank you all again for catching my stream, and I'll see you all tomorrow just for another normal LeetCode live stream where we'll continue where we left off on page 2. So I hope you guys all have a great rest of your Saturday. And yeah, like something fun just to top it off, I'm going to see Bad Bunny tonight here in a venue that's fairly close to me. So I'm really happy for that. I'm pretty excited for that. So I hope you guys have a really good weekend. And if you follow me on TikTok, you might see some videos of me there. So take it easy, everyone. Have a great rest of your weekend, and we'll keep in touch later. Happy coding.